Okay, we're going to finish up this Unit 5 Part 2 review. So we are ready for number 14, and it tells us to write this function in vertex form. So I'm going to do this problem two different ways, just in case you were taught differently by your teachers. Okay, so the first way I'm going to do this is using completing the square. So I'm going to rewrite this equation over here, so I have a little room. And so for completing the square, we separate the constant from the other two terms. And so we're going to try to figure out what would make this a perfect square trinomial. So we've already talked about that a little bit. If I was to take half of 4, that would be 2, and 2 squared would be 4. So I need a 4 back here to make this a perfect square trinomial. So I would have x squared plus 4x plus 4. And then I'm going to recopy the minus 6. But I can't just add 4 to a problem. And so I'm not adding 4 to both sides of the equals. I'm just working on one side of the equals. So if I'm going to add 4 to one side of the equals, then I have to also subtract 4. And that's so the 4 doesn't exist. Because then 4 minus 4 would make 0, and all you'd have left was what you started with. So by me adding 4 and subtracting 4, it's like I'm not really doing anything mathematically to the problem other than changing appearance. So now that this is a perfect square trinomial, then it factors with the parentheses and the squared. It's always the letter you're working with, and then whatever half this number is, and half of 4 is 2. And then I'm going to clean up the back. Negative 6 minus 4 makes negative 10. So that is one way of putting this equation in vertex form. Okay, I'm going to do it a second way, just in case somebody was taught differently. Okay, not that long ago, you were taught this formula to find the axis of symmetry. So you take the opposite of b. So the opposite of a positive 4 is negative 4. And then you take 2 times your a. My a is a 1, so 2 times 1 is 2. If I divide, I get negative 2. So I know my axis of symmetry is x equals negative 2. So knowing that, I know the answer has to be a or b, because it's asking us to put this in vertex form and also find the axis of symmetry. So I know that the answer is A or B. I also know what the answer is now that I put it in vertex form. So I know the answer is A, because that vertex form matches what I found. But if I was to continue going this way, remember whatever you get for your axis of symmetry is also the x coordinate to your vertex. What we need to find is the y coordinate. So there's a couple different ways of doing this. But one way is to go to your y equals in your calculator and type this equation in, x squared plus 4x minus 6, and then go to your table, and I want to look for negative 2 in the x column, and here it is, and so the y that goes with it is negative 10. So this means my vertex is negative 2, negative 10. Okay. So remember, the vertex is your h and your k. So when you write something in vertex form, it looks like this. And so what we need to do is we need to plug in our a, our h, our k. So it's going to go y equals, a is the number that's in front of the x squared, so a is 1. And then in parentheses, it's going to go x minus our h, which is a negative 2. But a minus and negative back to back makes a plus. Then I'm going to close it and square it. And then in the back, it goes plus your k, which is a negative 10. So instead of putting plus a negative 10, it'd look better if it just said minus 10. Okay, do you see? It matches. So this way is by using completing the square. or a form of completing the square. And this way is doing something that you've done before, just in the past. So hopefully one of those ways works for you and you like it. Okay, let's go on. Okay, number 15. It says to solve x squared plus 12x plus 36 equals 16 by using the square root property, you would first rewrite the equation as, okay, so all these problems that dealt with the square root property always had the left side already as a perfect square trinomial. So let's see if it really is. If you take half of 12, what do you get? 6. And if you square 6, what do you get? 36. So since the left side is a perfect square trinomial, then the left side's going to factor like that, where you put the letter you're working with and you write down half of the middle number, and half of 12 is 6. And then your 16 would just come down. And then from here I would solve it, but it's not asking me to solve it. It's saying you would first rewrite it as, well, this is how I would first rewrite it. So that is answer choice A. Okay, 16. It says we've got this quadratic equation. It's to be solved by completing the square. Which equation would be a step in that solution? Okay, so I have to know which of these would be a part of my process. Okay, so the left side is not a perfect square trinomial because we don't even have a trinomial. There's only 2 things over there, not even 3. So I'm going to need to make this side a perfect square trinomial. Now the constant's already on the right, which is what I want, because when you complete the square, get the constant on the right. So I'm good there. So I need to figure out what number is going to go back here. So what number are you going to put back here? And then, of course, if you put that number back there, you're going to have to put it back here too. Because when you're working with an equation, what you do to one side, you have to do to the other side. Okay, so what is half of negative 18? Negative 9. And what's negative 9 squared? Positive 81. A negative times a negative is a positive. So if I add 81 to this side, I have to add 81 to this side. This number back here will always be positive. I know several of my students were putting negative numbers there when they took this quiz, but when you square something, it always comes out positive. A negative times a negative is a positive. A positive times a positive is a positive. Okay, let's see if that's one of the things over here. Nope. Okay, so now this left-hand side, because it's a perfect square trinomial, is going to factor with the parentheses and the squared. It's whatever letter you work with, and then half of the middle number. And half of negative 18 is negative 9. And then I need to clean this side up. So I need to take negative 106 and add 81. And if I do that, I get negative 25. Okay, let's see if that's one of the steps. Ooh, it's so close. It was almost this one. Okay, so I have to keep going. So now we're going to do the square root property. To get rid of the squared, we square root both sides. Don't forget to slap down your plus minus. On the left-hand side, the squared and square root cancel, leaving x minus 9. And on the right side, I is going to take that negative out, and then you'll be left with a positive 25. And then what's the square root of 25? 5. So this is going to be 5i. Okay, and what do you notice? Here it is. That step matches. So I don't actually have to finish the problem, but if I was to finish the problem, I would add 9 to both sides, and then I would not be able to work that, so I would write the positive 9 and then all the plus minus junk, plus minus 5i, and that would be my answer. Okay, number 17. This is telling us to find the exact solutions using the quadratic formula. Now, if these answers were nice, I could just use my calculator to find the answers, but clearly these answers are not nice, so I'm going to go ahead and use quadratic formula. I could complete the square, but when your a is not a 1, completing the square is no fun. So quadratic formula, it needs to say equals 0 before you begin. So let's fix it. I'm going to drop my 2x squared. I'm going to move my 5x to the left by subtracting it. I'm going to move my negative 1 to the left by adding it. Now it says equals 0. Okay, so every time I work these problems, off to the side, I always like to list what my a is, what my b is, what my c is, and what my b squared minus 4ac is. And I do that so when I go to work the problem, I only have 3 numbers to put in my equation. So a is 2, that's the number in front of the x squared. B is negative 5, that's the number in front of the x. C is 1, that's your constant. So now to calculate b squared minus 4ac, you put parentheses where your b is, parentheses where your a is, and parentheses where your c is. So we said b was a negative 5. We said a was a 2. And we said c was a 1. Okay, so I'm going to type that in my calculator, just like I wrote over there. So parentheses, negative 5, close it, square it, minus 4, parentheses 2, parentheses 1. And when I calculate, I get 17. Okay, so our quadratic formula goes like this. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. That's our quadratic formula. So now I'm going to plug in what it tells me to. So I write x equals, it wants the opposite of b. What's the opposite of a negative 5? A positive 5. Plus or minus square root. We just found our b squared minus 4ac to be 17. All over 2a. And what do you get if you take 2 times your a? 2 times 2. 4. At this point, I would try to break down the square root of 17 or take the square root of it, but you can't take the square root of 17, you can't break it down. That's my answer. Do you see it over here? It is answer choice B. So that is quadratic formula. Okay. Number 18. It wants us to use the value of the discriminant to determine how many solutions and what kind. Okay, so the discriminant, remember, is b squared minus 4ac. Do make sure that these problems say equals 0 before you begin. Anything that has to do with quadratic formula, it needs to say equals 0. So if it says solve with quadratic formula, if it says find the discriminant, make sure it says equals 0. And it does. Okay, so let's build our parentheses where the b is, build your parentheses where the a is, build your parentheses where the c is. So looking over here, who is my b? My b is negative 1. That's the number in front of the x. I had some of my students putting negative x in the calculator, and that did not work for them. So please don't do that. It's whatever's in front of the variable. The a is a 3, and the c is a negative 12. Okay, then our handy dandy calculator to the rescue. Parenthesis, negative 1, close it, square it. Minus 4, parenthesis 3, close it, parenthesis negative 12, close it. And then I hit enter, and I get 145. So that's my discriminant. So I'm going to see if I can take the square root of it. And I cannot. So because this does not come out pretty, that means these answers are irrational. So I know we're going to have 2 irrational roots. So you get complex roots when you get your discriminant to be negative, and this was not a negative number. You get 2 real rational roots when this number is a perfect square. So if you got 9 or 16 or 25, etc. You get 2 real irrational roots when you can't take the square root of it. And the only time you'll get one answer is if your discriminant is 0. That's the only time you'll get one answer. Okay, number 19. Identify the vertex, axis of symmetry, and the direction of opening. Well, let's start with the direction of opening. That's easy peasy. If this number in the very front is negative, then the graph opens down. So I can eliminate A, because that says it opens up. Okay, so now, vertex form is handy because it tells you how the vertex moves. Remember, if it's in the parentheses, it goes left or right, and a plus makes it go left. There's nothing in the back, so it's not going to go up or down. So if you were at 0, 0, and you went left 2, what would your vertex be? Negative 2, 0. You go left 2, so that's your x, and then you don't go up or down, so your y is 0. And the axis of symmetry is always x equals whatever the x coordinate to your vertex is. So your vertex is negative 2, 0, and the axis of symmetry is x equals negative 2. So that puts B as our answer. Okay, 20. Which quadratic function has a vertex at negative 3, 5 and opens down? Okay, let's start with opens down. Which two are going to open down? B and D are going to open down because they have negatives in the front. So A and C are out. Okay, so let's just see what would have a vertex at negative 3, 5. I'm going to start with this one. A minus in the parentheses makes you go right. A plus in the back makes you go up. So if you were at 0, 0 and you went right 3 and up 5, would you be at negative 3, 5? No, you'd be at a positive 3, positive 5. So it can't be D. This is the winner. This makes you go left 3. This makes you go up 5. And if you go left 3, your x would be negative 3. And if you go up 5, your y would be 5. So B's it. So if you can remember those transformation rules, this is pretty easy. So I talked about it in the last video, but I'm going to just say it one more time. If it's in the parentheses, it goes left or right, but always opposite of your natural thought. Plus will make the graph go to the left, minus will make the graph go to the right. If the number is in the back, it goes up or down. But this does what you think it would do. Plus is going to make it go up, and minus is going to make it go down. So those are your transformation rules when the equation is in vertex form. Okay, let's keep going. All right, I believe this is the last page. All right, so 21. It wants us to write this in vertex form. Okay, so this was the problem that I did earlier, and I did it 2 different ways. So I'm going to do it the 2 different ways again, just because I'm not sure, how you were taught by your teacher. Okay, so one way of doing it is to use completing the square, or the process of that within here. So that is when you're going to separate the constant from the other 2 terms. And then you're going to try to figure out what number to put here, so this is a perfect square trinomial. Okay, so what is half of negative 18? Negative 9. And what's negative 9 squared? 81. Okay, so I need an 81 back here. So x squared minus 18x, and I need a positive 81 back there. And then I'm going to bring down my plus 52. Now, because I'm not doing anything with the left side of the equals, the left side is just a y, then I don't add 81 to this side and add 81 to this side. So I want this 81 to be like it never existed, because I need this problem to stay just like it originally did. So if you're going to add 81 here, you have to do the opposite and subtract 81 here. So like it doesn't exist. 81 minus 81 is 0. Shoop. Now they're gone, and you have your original problem. Okay. Whereas if I was adding 81 to one side of the equals, then I'd have to add 81 to the other side of the equals. That's the sort of thing when you're actually completing the square and solving for x, but that's not what we're doing here. Okay, so now this side is a perfect square trinomial, so it factors with the parentheses and the squared. You put the letter you're working with, and then half of this middle number. And half of negative 18 is negative 9. And then all I have to do is clean this up. 52 minus 81. So 52 minus 81, and that makes negative 29. Okay, that is my vertex form. And I see the answer is D. Now I'm going to do it the other way, where I start off finding the axis of symmetry. So this is how you were taught originally to find the vertex. And this was, you know, not this piece of the unit, but another part of Algebra 2. So the opposite of negative 18 is positive 18. If you take 2 times your A is 1. So 2 times 1 is 2. And if I divide, I get 9. So that's my axis of symmetry. It is also going to be the x-coordinate to the vertex. So to find the y-coordinate, I'm going to go to y equals, and I'm going to type this equation in. X squared minus 18x plus 52. And I'm going to go to my table, and I'm going to look for a 9 in the x column. And when I find it, I see a negative 29 in the y. Okay, so this is my vertex. Remember, the x-coordinate is the h, the y-coordinate is the k. Okay, so vertex form looks like this. So it would go y equals a, and a is 1, because that's the number in front of the x squared, so a is a 1. X minus h is a 9. Close it, square it, and then plus k, so plus a negative 29 or just minus 29. And you get that answer. So I don't know which method you prefer, but whichever method you prefer, then use it. Okay, 22. It says, which quadratic inequality is graphed below? Okay, so let's just do a few things real quick. Is the shading above or below that graph? The shading is below. So I need a less than or equal to. Now, is this graph solid or is this graph dashed? It's solid, so that means it needs to be a less than or equal to. Okay, where do you see a less than or equal to? You only see it here, so nobody else can be right. Now, if you were to set this factor, x minus 3 equal to 0, you would add 3 and get 3. If you were to set this factor, x plus 1 equal to 0, you would subtract 1 and get negative 1. This is where the graph would be touching the x-axis, and sure enough, it's touching the x-axis at a positive 3, and it's touching the x-axis at negative 1. So that's how you could check, you know, the parentheses if you had more than one answer choice that had less than or equal to. Okay, 23. It wants me to solve this inequality, and it is quadratic. So I'm going to set one side equal to 0. I did a couple of these in the last video. So I'm going to leave my x squared alone. I'm going to move the 2x by subtracting it. I'm going to move the 3 by subtracting it. Keep your sign the way it is. And we're going to try to factor this. So when I do this, my a is a 1. So it's the easy one. So I'm going to take a times c. So 1 times negative 3 is negative 3. I want the numbers to add to make negative 2. So what two numbers multiply to make negative 3 and add to make negative 2? A negative 3 and a positive 1. Okay, because it's the easy one, I got to go straight to the parentheses. I write down the letter I'm working with, and then I write down the numbers that we found. So negative 3, positive 1. And then I'm going to set each of these equal to 0. So if you set x minus 3 equal to 0, what would you get if you solved that? A positive 3. You would add 3 to both sides. What would you get if you set x plus 1 equal to 0? You'd get negative 1 because you would subtract 1 from both sides. So that means if I was to draw this graph, that it would touch the x-axis at negative 1 and it would touch the x-axis at 3. Okay, then this parabola is going to open up because your a is a 1. So I've got a parabola that opens up. So a rough sketch would look something like this. Because of the equal sign, these would be closed circles. And what we are interested in is where the y's are less than or equal to 0. Well, y's are less than or equal to 0 under the x-axis. So it would be from here to here that the y's would be less than or equal to 0. So my solutions are in here. So those are numbers between negative 1 and 3. And the symbols always go like this, and because they're closed circles, they would look like this. And so if I look over here to find the answer, it is A. Okay, last one. And it actually ends on a pretty easy note here. It's asking us to find the value of the discriminant. So once again, the discriminant is b squared minus 4ac. It's not even asking us to figure out how many answers or what kind. It just wants to know what that is. So remember, you want these problems to say equals 0 before you begin. So let's fix it. So I'm going to move this 2x. So to move a positive 2x, I'd have to do the opposite and subtract it. So the 2x squared would come down. 10x minus 2x makes 8x. And then my plus 9 would come down. And then this is now a 0. Okay, so to calculate our b squared minus 4ac, I put parentheses where my b is, parentheses where my a is, parentheses where my c is. Then I'm going to plug in what they are. So who is b? B is 8. That's the number in front of the x. Who is a? A is 2. That's the number in front of the x squared. Who is c? C is the constant. It's 9. Okay, let's just put this into our calculator. So, parentheses, 8, close it, square it, minus, make sure that's a minus, 4, parentheses, 2, close it, parentheses, 9, close it. And when you hit enter, you get negative 8. And that is our discriminant. And so that's the answer. That's what you would put in. If it wanted to know how many answers, there would be 2, and they would be complex because you would end up having to use an I in the problem. Okay, that's it. Good luck. Smiley face.